if sine theta is 3/5 and tangent is smaller than 0, you need to find cotangent theta and secant theta. Okay, so in this problem right here, it'll be better if we again do a little sketch. Right, so sine theta is 3/5, and from the previous example we already know that sine theta is only positive in the first and second quadrant. Alright, tangent theta is smaller than 0. Tangent theta is smaller than 0 whenever sine and cosine have opposite signs. So if sine is positive, cosine is negative. Alright, that happens in the second quadrant. Or sine is negative, cosine is positive. That happens in the fourth quadrant. Therefore, to satisfy both requirements, the angle must be in the second quadrant. So we can determine that this angle theta, we don't know what it is, but it must be in the second quadrant. Therefore, on the second quadrant, we're going to find a point. So this is going to be its initial side. All right, somewhere this is going to be its terminal side. This is the angle theta. If you say, well, does it have to be a positive angle? It could be a negative angle as well. That's true. Doesn't matter. They are coterminal angles. And as long as they are coterminal angles, they have exactly the same trigonometric function values. So really, what it matters is what it look in this standard position. Okay. So this angle has sine value of 3/5. We know that if we find a point on the terminal side and the point has xy coordinates and also a distance r which equals to square root of x squared plus y squared, then sine theta equals to y over r and cosine theta equals to x over r. So in this case, because we know sine theta is 3/5, therefore we want simply to set y equals to 5 and 3 and r equals to 5. This way, sine theta is indeed 3/r, which y over r, which is 3/5. Now, x can be calculated by reversing this equation. Therefore, x could be either positive or negative, square root r squared minus y squared. However, because we already know this angle has the terminal side that's in the second quadrant, therefore we can tell for sure that x has to be negative. Therefore, this equals to negative 25 minus 9, negative square root of 16, which is negative 4. So with x and y and r, all of them now known, we can now determine, we can actually determine all 6 trigonometric function values if we want to. Sine theta equals to 3/5, cosine theta equals to negative 4/5, cotangent theta equals to 1/tangent or cosine over sine, so that equals negative 4/3. Secant theta equals to 1/cosine, so 1/negative 4/5, and that equals negative 5/4. And that answers our questions. Last problem. Again, if angle theta is in standard position and you are given a point on its terminal side, you're asked to find cosecant theta and tangent half a pi minus theta. So again, let's do a little sketch. So now you already know that this angle theta is given in the standard position initial side, and one point on its terminal side has coordinates -2 and -5. That's your x and y. So this point right here has coordinates -2, -5. So as you can already tell, this angle, it could be this angle right here, it could be this angle right here, it doesn't matter. The terminal side is in the third quadrant. Okay, and then we can determine r as well. R equals to square root of x squared plus y squared. In this case, square root of -2 squared is +4 plus -5 squared is 25, and this is square root of 29. Okay, so this right here, distance is square root of 29. So with x and y and r known, again, we can find the 6 trigonometric function values for this angle. But we're only asked to find first cosecant theta, which equals to 1 over sine theta. And sine theta is y over r. So in this case, cosecant theta is r over y, which is square root of 29 over negative 5. Therefore, negative square root of 29 over 5. For B, find tangent half a pi minus theta. Now, you need to understand that half a pi minus theta, this angle right here, and angle theta are complementary angles. Why? Because remember, complementary angle says that if alpha plus beta equals to half a pi, they are complementary angles. In this case, half a pi minus theta, that's our angle number 1, plus theta, that's our angle number 2. They add together exactly half a pi. Therefore, this angle is a complementary angle, and according to the complementary property, their co-functions equal to each other. Therefore, tangent half a pi minus theta simply equals to cotangent theta. Okay, and we can definitely find cotangent theta. Cotangent theta is x over y. In this case, x is -2, y is -5. So this